Welcome to the video lecture. In this video, we are going to see what is basis path testing and solving a problem based on this testing. Basis path testing is a white box testing technique, and it enables the designer to derive a complexity measure for a procedure given, and it defines a set of execution paths. So the procedures involved in doing basis path testing are finding the flow graph notation and calculating the independent program paths and deriving test cases, and then executing graph matrices. So the flow graph notation is a simple notation used for the representation of a flow of your procedure, which is also called a flow graph or program graph. So here is the structured constructs. Here are some of the structured constructs for the flow graph, and if your program is sequential form, it is represented like this, in this way. And if your program is using if condition, if the this node represent your condition, and if it's satisfied, it execute this node, and if it is false, it execute this node, and after the statement, it will execute the next statement. These nodes represents the procedural description language, that is statements, source code statements. And for while loop, this is the node containing your while condition, and if the condition satisfies, it will execute the statement and it will become a loop, and if the condition is false, it will execute the next statement. And for until loop, if the condition is true, until the condition is true, it will execute this statement, and then or else it will move on to the next statement. So this is the flow graph we can use for switch case. So for case 1, case 2 up to case n, we can represent using the switch case using this flow graph notation. And then this is the difference between a flow chart and a flow graph. This is the way your flow chart look like, and this is the way your flow graph should look like. It consists of nodes, and these are represented as nodes, and it also consists of edges. So the line connecting the nodes are represented as edges, and the region present between the nodes are called as region. So for example, this is one region, and this is one region, and this is another region, and this is another region. So there are 4 regions represented here, which is denoted by R1, R2, R3 and R4. And there are also called nodes called predicate nodes. That is, the nodes having a condition is mentioned as predicate nodes. For example, if it is having a condition, that is, if it is having more than one branch, then a condition may be present in this node. That is, if the condition is true, it will execute this statement, or else it will execute this statement. So if your flow graph consists of more than one branch, then that particular node consists of condition. So that node is represented as predicate node. So 1, 2 and 3. These 3 nodes are represented as predicate nodes here. So next step is find the cyclomatic complexity to find the independent paths. The cyclomatic complexity can be calculated using 3 ways. One is the number of regions. We can calculate the number of regions present in your flow graph, and then the second way is E minus n plus 2. V of G represent your cyclomatic complexity, and E is the edges, and n is a node. So E minus n plus 2, which provide you the cyclomatic complexity of your procedure. And the third part is we can add 1 to the predicate node. V of G can be calculated using P plus 1. P represent your predicate node. So these are the ways to find your cyclomatic complexity. So if I'm having this control flow graph notation, so for this flow graph, we can find the cyclomatic complexity as mentioned here. So the flow graph has 4 regions, 1, 2, 3, 4. So the complexity is 4 by using this way. And the next one is V of G is equal to edge minus node plus 2. So here there are 11 nodes and 11 edges and 9 nodes. So 11 minus 9 plus 2, which is also equal to 4. And there are 3 predicate nodes, 1, 2 and 3, and 3 plus 1 is equal to 4. So this is how we can calculate the cyclomatic complexity. In any of the 3 ways, the complexity we have calculated should be same. So after finding the complexity, we have to find the independent program path. That is a path through the program that introduces at least one new set of processing statement or a new condition. So from this, from the given flow graph notation, we are going to find the independent program path. So as per the complexity we have calculated, cyclomatic complexity we have calculated, there are 4 independent paths available. So here, start from 1, we can directly run to 11. So 1, 11 is one path, and then 1, 2, 3, 4, 5, 10, 1, 11 is another path, and 1, 2, 3, 6, 8, 9, 10, 1, 11 is another path, and 1, 2, 3, 6, 7, 9, 10, 1, 11 is another path. So there are these 4 independent paths present in your program. So based on the logics we have learned, we are going to derive test case for the given procedure. This is the given procedure, and we are going to derive test case by numbering the procedure and then constructing a flow graph and then calculating the cyclomatic complexity and finding the independent program paths. So these are some of the information they are given for what type, what interface they are using, and from this statement I is equal to 1, your program starts. So we are going to numbering the program from this statement I is equal to 1. So I am numbering the first initializing statement as 1, and then the second statement, the condition given in this statement, this condition is stated as 2, and this one is considered as 3, and the next statement is considered as 4, and in the next statement there are 2 conditions, one is considered as 5 and another one is 6, and then 7, if 5 and 6 satisfies, then it will execute 7, and then after 7 it will execute 8, and 8, then the next statement is end of the do while statement, which is stated as 9, and then there is a 10th statement which is also having a condition. If the condition satisfies, it execute 11, or else it will execute 12, and 13 is the end of the if statement. So there are totally 13 nodes, that is each statement present here are considered as nodes. So for these 13 nodes, we are going to construct a control flow graph. So using the code as a foundation, we are going to draw a corresponding flow graph. So this is a flow graph. So this is how we have to construct the flow graph. So from 1, it will execute 2, and then 3, and then it will execute 4, 5, 6, 7, and if 5 and 6 is true, it will execute 7, and if 5 and 6 is false, it will directly execute 8. Hence, that is a edge connecting 8 here, and then after 7 and 8, it will execute 9 statements. So 7 and then 8 and then 9. Here after 9, the loop ends here, do while loop ends here. So after 9, it will again execute this second statement. It will move on to until the condition satisfies, the loop will execute here. So here after 9 statement, it will move on to 2. And here after the statement, if the condition is true, it will execute the sequential statements, but if the condition do while condition is false, it will move on to the 10th statement. So we have to construct the flow graph from here. So after checking 2 and 3, if the condition is false, it will move on to 10, and here also there is a condition. So if the condition is true, it will execute 12, 11, and or else it will execute 12 and then move on to 13. So this is the control flow graph we have constructed for the given procedure. So after constructing the control flow graph, we have to find the cyclomatic complexity for the flow graph. And here there are 1, 2, 3, 4, 5, and the outer region, which is also included, which is region 6. So there are 6 regions. So that represents the cyclomatic complexity, and another way of finding is E minus n plus 2. So there are 13 nodes and 17 edges. So 17 minus 13 plus 2, which is also equal to 6. And there are 1, 2, 3, 4, 5 predicate nodes. So V of G is equal to P plus 1. So 5 plus 1, which is also 6. So the cyclomatic complexity we have calculated in any of the 3 ways results in 6. So this control flow graph consists of 6 independent program paths. So the next step is finding the basis set of linearly independent paths. So path 1 is So I'm going to execute from 1, 2 and 3 are both the condition given in do while. So if the condition is false, then it will execute 10. So 1, 2, 3, 10, either it will move on to 12, 13 or it will move on to 11, 13. So there are two paths here, 1, 2, 3, 10, 11, 13, 1, 2, 3, 10, 12, 13. And the next one is, if the condition is true, it will move on to 4. So 1, 2, 3, 4, 5, 6, and if this condition is true, it will go to 8. So 5, 6, 8, 9, 2, again 2 and 3, and there are two ways, 10, 11, 13, 10, 12, 13. And the next is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 10, 11, 13 one path, and 10, 12, 13 one path. So there are totally 6 independent paths we can get using this control flow graph. So next step is finding the graph matrix. A graph matrix is a square matrix that is consists of number of rows and columns, so which is equal to the number of nodes on your flow graph. So each row and column corresponds to an identified node, and the matrix entry corresponds to the connection between the nodes. So this is how you have to represent your flow graph into a graph matrix. So this is a flow graph. For example, consider this flow graph, and it is having 5 nodes, and each edge is having a value. So here the node is represented here, and the connection nodes are represented here. So one is connected to 3 through A. So 1 is connected to 3 through A, and 3 is connected to 2 through D. So 3 is connected to 2 through D, and 3 is also connected to 4 through B. So here it is mentioned, and then 4 is connected to 2 and 5 through C and F. 4 is connected to 2 and 5 through C and F. And 5 is connected to 3 and 2 through G and E. 2 and 3 to G and E. So this is how you have to represent the graph matrix for the given flow graph. So thank you for watching the video.